Okay, let's talk about emotions. So emotions are generated in what's called a limbic circuit. A bunch of different nuclei spread across the brain. But all of these nuclei tend to be subcortical, meaning they're not in the cortex of the brain, but in deeper areas such as your amygdala, even hippocampus, your fornix, or all areas that's involved in this kind of limbic circuitry. So the way it works is this: your subcortical areas of the brain, things like your hypothalamus. I'm going to mention these two: hypothalamus and the amygdala. These areas will generate the emotions. Okay. So these areas generate emotions. Different stimuli come in. Like, for example, you may smell something and that gets relayed over to here, where then you create an emotion maybe of I'm happy or I'm sad based on the odor, the memory of the odor. All those things come together to create an emotion. Okay. So then once you create emotions, then these areas will relay that information to two areas. They will relay to your hypothalamus. So even if it's made here, it will get sent to another part of the hypothalamus. So the hypothalamus. And this one will control then the autonomic responses to the emotions. For example, if you're upset, that emotion will trigger the hypothalamus to cause your blood pressure to go up or your pupils to dilate. Those are ANS things that happen. Okay, so the autonomic responses are being controlled by the hypothalamus, and then you also send the emotions over to your prefrontal cortex, where here you control how you express it. So the expression of the emotion, right? If you are mad and you are with your boys or your girlfriends, you're mad, you say you're mad and act mad because you're with friends. If you're mad at work, you tend to hold that in because it maybe at that moment is not appropriate to express your anger. And that's the job of this part of the brain, to determine when and how you express an emotion. So it's more voluntary expression. This one is involuntary show of emotion. This one is a voluntary show of emotions over here. And typically this part of the brain, the wiring that goes on here to control the frontal cortical expression happens later on, probably in your 20s, late 20s even. That's when you start to get a nice control of your emotions. Earlier, it's hard to control it that much because the circuitry is not really wired well enough yet to tamper down on your explosiveness, but in terms of emotional expressions. Okay, so that's emotions. Let's go to movement. So movement, right, it begins in your premotor cortex or your motor association area, what we call your premotor cortex. This area is where you will have intentions. The intentions are the motivation to move, and also where you will create the plan of how to move. So your movement plan. So both intentions and the blueprint of how to move are done here. And then this area will then relay that information over to your primary motor cortex. And this part of the brain is what will then know which muscles to engage or how to engage muscles. So here, you send the plan over here, and then this area will command the appropriate muscles at the right time to execute the movement. So here, primary motor cortex will send down neurons that will synapse in the spinal cord or brain stem, and then from there, neurons go out to the muscles to then cause the movement there. Okay, so these two neurons are given names. So the first set of neurons are called your upper motor neurons. They're the ones that carry the commands down from the primary motor cortex to your brain stem or spinal cord. And then the lower motor neurons are the ones that go out eventually to your muscles to activate them so that they move and create a movement of interest to you. Also here, the plan of action is also relayed to your cerebellum. So it knows what you're trying to do. And then the cerebellum as well gets input from your receptors, from your muscles, your muscle tendons, your muscle spindles, also your eyes will tell it. Right? Receptors in the periphery will feedback to let it know what you're doing. So this part will say, this tells you the intent. What you're trying to do comes down from the premotor area to the cerebellum, and this is a feedback of what you're doing from your muscles. And so the job of the cerebellum is to compare what you're trying to do with what you're actually doing. So it's a comparator. And it will then feedback to here to let it know if there is a difference between what you're trying to do and what you're actually doing, and allow for you to adjust your action to then make these two match together. Your intent will match with your action, okay? So this is how you get precision. So your cerebellum allows for precision of action. It allows for you to really be coordinated to match exactly what you're trying to do with what you're doing. Okay. All right. When this goes offline, you have what's called ataxia, clumsy movement. It's also the area that gets affected by alcohol. When you're drunk, it goes offline and you become clumsy in your movements because you can't adjust on the fly what you want to do with what you're actually doing. Okay. All right. There's also another area that's involved in movement called your basal ganglia. The basal ganglia, things like your substantia nigra, for example, is involved in making dopamine, which is involved in movement, right? And so when the basal ganglia is offline, you get what's called dyskinesia. Dyskinesia. Okay. And in this condition here, it's hard for you to start a movement. So it's hard to start or initiate movement. Can't start movement. Because that circuit is affected. Okay? This is what happens a lot in Parkinson's disease. The nigra stops making dopamine, and then a person's kind of stuck. They can't start a movement because the circuitry is off in some way. Okay, we'll stop there for now.